Hello class. I wanted to show you something interesting that I've done in my first part of the analysis here. I'm doing this project right along with you, and hopefully you've had time to do the first part of this analysis where you're putting in the data for the US and then trying to model that with an equation. So uh, this first part of the data, notice that it goes up, and a lot of people in the news are talking about exponential growth. So of course it makes sense to model this first part with exponential growth data. But you'll also, I hope you can see on the video, if not then you can kind of zoom in when you put the data in yourself. If you notice that this appears to be that we could already be at a sort of an inflection point here where the concavity shifts and it begins to go downward. Now, the interesting thing is I stopped at this point right here when I was doing my analysis because I was doing this yesterday, and I have not added in the point for today yet. So I wanted to see if my model could sort of predict what the value for today would be fairly accurately. So I think that's going to be interesting. So I did not put in any data past 51,900. But I did notice that it looks exponential to here. This is the day that we started closing down schools and closing down businesses and a lot of things in the media, social distancing, all of these things started on this day. And then that's actually when the curve immediately started to shift, which I really expected it would be about a 14-day delay before we saw any sort of shift. I think that after 14 days there'll be a different level of shift, but we actually can see a little bit even beginning in these first few days. So here is the analysis that I've done, and if you haven't done your own analysis yet, I recommend that you do so, and you can pause the video and you can come back to it to see if there's a similarity with what we have. So first of all, I put in all of the data. It's in these green points for Y1, and I put in all of the data up to 59 days. That is the exponential growth portion. I believe it was on the 60th day, according to that chart, when we actually started closing things down. And so that's when I saw that little bit of a shift. So I wanted to model that separately. So I put in these last 5 days separately, and that's because we don't actually have data for the current days that we're in until the World Health Organization is really sure of the data. It takes a few days for them to put out what the numbers really were. So these numbers are the numbers for what's actually today, which is Thursday, are going to be more than these amounts. We see that they're still going up, but these are the data that we're sure about. So I wanted to see if we could use that in a predictive way. So what I've done is I set up an exponential growth regression here, and I wanted to see, look at this, 9.9883 is my R squared value. So a really good fit with this, and I have the parameters A and B there. And when I turn that on, you can see that it is a very good exponential fit. But what you notice is it is getting very steep very quick. So what I did was I made a version of that that's purple, and I can say I really only want that to go up to when x is less than or equal to, what was my number? 59. And that way it'll show the exponential curve portion, but it doesn't need to extrapolate on out after that. Now for the other portion of the graph, I put in Y2 in a separate grouping here. I made these last 3 points, and let's take out the one that actually happened today. So if I take those out and I just model looking at those 4 points, and notice this jump from here to here is much more than from here to here, and this is more than from here to here. And so we're actually decreasing in how far we go up. So it seems more like a logarithmic curve, and that's why I modeled this with a logarithm instead of with a exponential. So here we go. Here's the logarithmic curve here in green. And if I just redraw that so that I'm only looking at from 60 and up, you can see that these models almost connect here at this value. And then I'm at a very good 0.985 r squared value in modeling this. And so the interesting thing that happens is actually if we look at the difference between the purple line and the black line, I'm going to zoom in here so that you can really see the difference between the purple line and the black line. Notice that on day 64, the black line, the logarithmic curve, is at about 65,000. So that's a prediction for what would happen on the 64th day. If this continued to be exponential like it was to begin with, then we'd be looking at 81,600. And so I think there's really good evidence for there actually being a change there, because when we look at the 64th day, we have 63,600. Very, very close to the prediction made by this black line. This black line is actually a little bit higher. And so that's why I went back to the data and I said, if I put in the 64th day now is 63,600, then it will recalculate this graph and it will say, so now I want to look at the 65th day. And if I go up here, so I made a little slider so that I can change this to the 65th day. And I can look at where those intersect very easily, 75,400. So when the data comes out tomorrow, the data should come out on Friday, extending this by one more day. My model is saying this should be 75,400, and that's good news because it means that this is no longer exponentially curving upward. It means that the slope is actually lessening as we continue forward. And so if I were to zoom out here, you could see that even though this black line is going up, 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 it is not going exponentially up, up, up. It is curving over that way. Now, this is not to say that we're going to get up above 200,000 or anything like that, or above 1 million cases, because this is really only effective for this small portion of the graph when we're within 14 days, which is actually, it was day 51, I think, when we started all of these, or no, I'm sorry, it was over here a little bit further. When we started, it was right around day 60. So this could be through day about 75, through about here, it could possibly really balloon up to a high value, and this model could be appropriate for this part. But after this part, it's definitely going to need a new model. We expect that this is going to be coming down because you're really not having as many new cases, and the people that were getting infected here would now be through and recovered and done with the sickness. And that will actually lead us to the next part of our discussion, which is called the SIR model. And it will be using derivatives and using some more advanced modeling ideas to look at this beyond just looking at the data that we have and projecting in a close way, what will be next. But I think it's going to be very interesting if the data comes out on Friday and the value is close to 75,000, because that implies we're no longer going exponential. It would imply exponential if we're at about 114,000. So that'll be something to look for. All right, if you have any questions, let me know. I want to give you some time to make sure that you're able to do this analysis and look through things. But once you are done, please send me a message so that we can jump into that SIR model portion of this project. Thanks.